Hi guys, today we're going to be rearranging equations, and the notes for this are going to be super short since we already took notes on solving equations. It's going to be all the same information. You just won't be able to combine any like terms. So it's going to feel really strange, but we're just going to do a bunch of practice problems. So you might want to pause now and write down what I have so far. I haven't thrown any language up or remembering, but solving an equation for a specific variable. On the test, you'll see this a lot. I'll get into it. It'll say solve for x, solve for a, solve for y. And that's the variable you're going to isolate. Okay, so let's put that under remember. Solve for. Okay, that's the variable you're going to isolate. Okay, isolate, remember we used that in our academic language a little bit ago. It means to get by itself. Okay, and the second star, just the same steps as an equation. So let's just do a bunch of practice problems, and there's only a multiple choice quiz on Schoology when you're done with this, so don't forget to take that. But let's start with the volume of a cone. Okay, the volume of a cone, and the formula for the volume of a cone is 1/3 pi r squared times the height of that cone. So if you had a cone here, the height is from the tip of the cone to the center of the cone. That's the height, and the radius is from the center of the circle to obviously the outside of the circle. That should be review. But let's say this is how you find volume, but let's say we want to solve this equation for the height. I want to know the height of this equation given the volume and the radius. That means we need to isolate the h. So if we solve for the height, that means we isolate the h. Okay, so solve for means to isolate that variable. So let's see here. I'm going to, first of all, let's work this forwards. If we take the height, we multiply it by the radius squared, we multiply it by pi, and we multiply it by 1/3. Multiplying by 1/3 is the same as dividing by 3. So we could go about this a couple different ways. Let's divide both sides by pi times r squared. So let's rewrite this. Okay, if I divide this entire side by pi r squared, that means it's the same thing you do for one side, you do the exact same thing to the other. I'm going to divide volume by pi r squared. And on this side it cancels out because pi and r squared are on the numerator and pi and r squared are on the denominator. But we can't cancel out anything on the other side, and it's going to start at the beginning to feel really frustrating, but it'll be really helpful in the end, especially when you get into your sciences. You're going to need to do this for your formula a lot. So now what do we have? I'm going to start actually with the right side. I still have 1/3 times h, so I'm going to put that here on this side, equals v over pi r squared, and that just stays like that. You can't do anything about it. And now to get rid of the 1/3, the multiplicative inverse of a fraction is just to flip that fraction over. So to get rid of the 1/3, I want to multiply by 3 over 1. Okay, and what that means is you are going to end up with 3 over 3, which is just 1 whole, so it cancels out. But what you do to one side, you have to do to the other. So I'm going to multiply this side by 3 over 1, which happens to be just 3. So this cancels. So we have h is equal to v over pi r squared, that entire quantity times 3. You could also put the 3 in front. It could also look like this. 3 times v over pi r squared. All right, let's try another one. Let's look at the circumference of a circle. The formula for the circumference of a circle is pi times the diameter. And let's say we want to solve this for pi. What this equation is saying is that the circumference is equal to pi times the diameter. So the opposite of that, the inverse operation, is to divide both sides by the diameter. So the diameter cancels out here because we have a diameter on the numerator and the diameter on the denominator. And the other side, you can't cancel it out because you don't have any like terms. So I've already isolated pi. Okay, I've gotten it by itself. But I'm going to rewrite it pi first, because you can always flip what's on one side to the other of this equal sign. So I'm going to put pi is equal to the circumference divided by the diameter. And since pi is always the same number, any circumference and any diameter is always going to give you 3 pi, 1, 4, yada, yada, yada. Also, this is really cool. Since pi is a constant, this function is what? This function is what? A direct variation. Whoa! We are making connections all over the place. Let's keep going. Let me just throw some weird ones at you, okay? These aren't formulas for anything that I know, but let's solve some. This one's interesting. If we have an equation, we have a times x plus y equals b times x plus y. Okay? I want to solve for a. This is really just one step. Oh, this is so cool. Look what I can do. If I'm doing a times x plus y, I'm just going to divide by that entire quantity, because that's going to cancel out. No matter what's on the numerator and what's on the denominator, if they're exactly the same, it's going to be 1. It's going to be one whole. What you do to one side, you have to do to the other side. But look what happened there. I had the same thing there, so it's actually going to cancel out on both sides. So this one solves for just a equals b. Okay, and that's really cool. These things are just like puzzles. I love figuring them out and then getting your answer. So I've isolated a. I have one more written down here, and you can go ahead and go online and look at the Schoology quiz. This one I have. Yes, this one actually looks like a formula. I don't know what it's for though. And it doesn't matter. That's the cool thing. You can do math even if you don't understand what the formula is. That's what you're going to learn in chemistry and physics and all of the sciences, what all of these formulas mean. And math is like the language that you use. So what if we want to solve this for u? Whoops, for u. So we want to get u by itself. So let's take a look at u's our starting point. If we want to get it by itself, so we're taking u, we're adding v, we're dividing by 2, and that's all in parentheses, and then we're multiplying by t. So let's undo this like we would a normal. The last thing that we did is we multiplied by t. So the first thing I want to do to solve for u is divide both sides by t. Okay? So if I divide by t over here, and that actually is the whole side. I just put it over there. Dividing the whole side by t, I'm dividing s by t. That cancels, one on the numerator, one on the denominator, but s over t can't be reduced, so it stays the same. So now we have s over t equals u plus v divided by 2. Now I can multiply both sides by 2 because I'm taking a number, I'm adding v, I'm dividing by 2. The last thing I said is divide by 2, so I want to get rid of that first. So let's multiply both sides by 2. And you can think of it as 2 over 1 because it's a fraction. And any number over 1 is a fraction. You can turn any number into a fraction. Do the same thing to both sides by 2 over 1. Here I have a like dimensional analysis, the same thing on the numerator, the same thing on the denominator. And on this side, if I just multiply 2 times s, I get 2s. And 1 times t, I get t. So now I have 2s over t equals u plus v. So I just have one more thing. I want u by itself. I've got to subtract v, because you're thinking about what's happening, what operation is happening between the variable I'm solving for and the other variables. And so I'm adding v. So I'm going to subtract v, and I have to subtract v from both sides. So here I get 0, because no matter what number it is, if I take that same exact number away, it's going to be 0. I don't have to leave it there. And now I've isolated the variable, u equals, and then I'm going to rewrite this as the fraction 2s over t minus v. And you know me, I like to rewrite it as my isolated variable first. So I'm going to write u is equal to 2s over 2 minus v. So, I don't know what just happened there. Please let me know if you have any questions. This is tricky. I'd like to go over some in class also, but I need to make sure you have these practice problems and these notes the next time I see you for class, and to try the Schoology quiz over rearranging equations. There will be 2 of these problems on the unit test that we're going to take coming up here really soon. It's going to be a quick unit.